Hi, my name is Dexter Bateman, and this is a video summary of the paper Smoking During Pregnancy, Postnatal Effects on Arousal and Attentional Brain Systems by Garcia-Rill, Buchanan, McKeon, Skinner, and Wallace, which was first published in NeuroToxicology, Volume 28 in 2007. When mothers smoke during pregnancy, nicotine from the smoke can cross into the placenta, and fetuses of the mothers are exposed to high nicotine concentrations. Prenatal exposure to cigarette smoke is known to produce lasting arousal, attentional, and cognitive deficits in humans. Furthermore, prenatal exposure to cigarette smoke results in lower birth weight and increased incidence of sudden infant death syndrome and deficits in memory performance and learning. Dr. Garcia-Rill and his colleagues were interested in the effects of prenatal exposure to cigarette smoke on particular brain regions related to arousal and attention. One area of interest is the pedunculopontine nucleus, or PPN, which is the cholinergic arm of the reticular activating system. This figure shows the major connections of the reticular activating system, especially projections from the PPN, which are shown in yellow, to the intralaminar thalamus. The reticular activating system is responsible for controlling sleep-wake transitions and rapid eye movement sleep. PPN cells also express alpha-4-B2 subunits containing nicotinic receptors, which have previously shown to be upregulated as a result of prenatal nicotine exposure. It is thought that this early exposure may have adverse effects on the reticular activating system later in life. The authors hypothesize that a lack of developmental decrement in REM sleep will lead to lifelong increases in REM sleep drive, such are present in schizophrenia, anxiety disorders, and depression. To investigate this, the authors exposed pregnant rat dams to cigarette smoke and studied the effects on the intrinsic membrane properties of PPN neurons throughout neural development, and the manifestation of the P13 potential, the rodent equivalent of the P50 mid-latency auditory evoked response, which is considered to reflect PPN neural output. On embryonic day 11, pregnant dams were introduced to a plexiglass smoke exposure chamber. On E12 and E13, they were exposed once and twice a day, respectively, to 150 milliliters of cigarette smoke for 15 minutes. From E14 until parturition, the rats were exposed 3 times per day. The average exposure over the 15-minute period was 9.7 plus or minus 0.8 parts per million nicotine. 40 pups were anesthetized and rapidly decapitated when they reached 12 to 21 days old, and their brains were dissected into 400 micrometer slices for intracellular recording. The properties measured included membrane input resistance, wherein hyperpolarizing pulses 500 milliseconds in duration at 0.1 to 0.3 nanoamps were applied at the resting membrane potential, action potential amplitude, duration, and threshold, after hyperpolarization amplitude and duration, and changes in the hyperpolarization activated cation current IH. Other litters were implanted for recording of the P13 potential when they were 28 to 30 days old. Auditory evoked potentials were recorded from the vertex of unrestrained, alert rats placed in a sound attenuating chamber. Stimulation consisted of pairs of 100 microsecond clicks delivered at 500 millisecond interstimulus intervals and a 5-second intertrial interval until 32 pairs of evoked potentials had been averaged. This table shows the basic membrane properties of PPN neurons from exposed pups, born to dams exposed to cigarette smoke during pregnancy, and control pups. Several of the properties of PPN neurons from the exposed pups were significantly different. In exposed pups, resting membrane potential, or RMP, was decreased. Action potential threshold was also decreased. Action potential amplitude duration was increased, and the hyperpolarization activated cation current IH was significantly higher. These graphs provide an alternative look at this information. The top graph displays IH amplitude throughout neural development, from age 12 to 16 days on the left to 17 to 21 days on the right. IH amplitude in cells from exposed pups the NIC line on top, was also significantly higher than that of control cells, regardless of age. There is also a significant increase in the mean IH amplitude in both the exposed and control offspring between each age group. However, the steeper curve on top represents a much greater rate of increase in IH amplitude throughout neural development in the exposed pups. The lower graph displays current recordings from day 19 exposed cells and day 21 control cells. The exposed PPN cells displayed significantly lower resting membrane potential than the control, at minus 54 millivolts on the left, as compared to minus 63 millivolts on the right, and you may once again notice the greater IH amplitude for exposed cells. The P13 amplitude was measured using a conditioning stimulus given first, followed by a second identical test stimulus given 500 milliseconds later. Habituation to the stimuli was calculated as the ratio between the P13 response to the test stimulus and conditioning stimulus. Normally, the test stimulus will elicit a much smaller response as the auditory system adjusts to the conditioning stimulus. In general, there was a slight decrease in P13 amplitude for exposed pups in response to these stimuli. More interestingly, however, this graph indicates that the habituation of the P13 potential to repeated stimuli was significantly lower in the exposed litters than that of the unexposed litters. In this figure, taller bars represent reduced habituation. So what does this all mean? Prenatal exposure to cigarette smoke leads to changes in the development of some of the intrinsic membrane properties of PPN neurons. Decreased resting membrane potential and action potential threshold shown before would tend to make PPN neurons more excitable. These effects would increase tonic activity and synchronization of fast cortical rhythms during waking and REM sleep. These changes may likely be accounted for by the increased IH amplitude in exposed offspring. Channels mediating IH changes are made up of hyperpolarization activated cation nucleotide gated or HCN subunits. It is likely that changes to these proteins could be responsible for the arousal and attentional deficits and impulse control problems seen later in life. The effects of prenatal exposure manifest itself both in a small decrement in level of arousal, in the reduced P13 amplitude, and decrement in habituation to repetitive sensory input. The decreased habituation suggests some level of impaired auditory gating in the exposed rats. The P13 is the rodent equivalent of the human P50 potential, which has been found to manifest decreased amplitude and habituation in disorders such as narcolepsy, schizophrenia, anxiety disorders, and autism. In conclusion, prenatal exposure to cigarette smoke increases the excitability of PPN neurons early in development by increasing the amplitude of the hyperpolarization activated cation current IH. These effects continue with mild decrements of the P13 potential amplitude, indicating a slightly decreased level of arousal, and decrements in habituation to repetitive sensory inputs, suggesting a sensory gating deficit. These findings could help explain some differences between children born to mothers who smoked during pregnancy, especially in considering hypervigilance and increased attentional deficits and cognitive and behavioral disorders. Hopefully this information will also help persuade future mothers to forego smoking while they are pregnant. Thank you very much.